So next couple days, I don't see you guys again until Monday. If you looked at the schedule page, I was supposed to send you an email out as soon as I updated all that stuff, and then I totally spaced it. But I put your out-of-class due next Wednesday, and the same day the in-class will be. So you were supposed to have an in-class exam today, which was dumb, because I said, that's ridiculous. You don't have class on Monday. Let's use Wednesday as like a question day, and then we can have the exam week 8. So I was going to put the exam on Monday. I thought that was a dumb idea, because number one, you've got a project due that day, and number two, it's Monday. And I don't like getting like that kind of stuff on Monday, because... So I put it on Wednesday. But then I kind of figured I had to have the out-of-class due in a reasonable amount of time, too. So I put that due on Wednesday as well. I don't think it's that big of a deal. Hopefully it's not, because you've got plenty of time to work through it, and it's really a lot of Excel work more than anything. It's tying the ideas that we're doing in class into Excel. So you're entering some formulas, dragging some formulas like you did in the first project, and seeing how stuff ties together. There's like 3 questions. One of them is I took the last names of everybody in your class and the other 243 class, put them into one big distribution, and I asked you to find out, are there any unusually long or short names? Oh. And I tell you guys to pick how you define unusual. So we have those couple different ways. We have the inner quartile with the modified box plot way, 2 standard deviation way, outliers. Find the outlier names. And I don't tell you which one to use. I say go find the ones that are unusual in any way you want to. Just tell me why you picked the way you do it, and find the ones using that way. But this gives you plenty of time to do that. I wouldn't do that on an in-class assessment, because it seems like those kinds of open-ended questions freak people out, because they want to be told what to do on an in-class exam. So I put that on the out-of-class. The next part of the out-of-class is looking at percentile ranking through Excel, using Excel to do it. And then the last part is using probability distributions, creating them in Excel. So the X and P of X columns, and then finding averages and things like that using Excel and kind of analyzing them. So it's kind of, again, it's just like a little deeper look at the same stuff we're looking at in class. And it's the same topics that'll be on the Wednesday in-class exam, but on a much more superficial level of the in-class exam on Wednesday. Much more straightforward. Here's a distribution, give me the average. Okay. Not here's part of a distribution, make the rest of it, and then give me the average. I mean, that's the kind of stuff that freaks people out. So, I know. Looking out for you, looking out for you. So, today, what I want to start with today is any questions that you guys have. I know we've talked relative position quite a bit, and I think we've got a good gut feeling about that. Anything from either of these 2 sets of problems that you want to look through? Please, Madeline, yes, which one?
E3 on outliers.
Oh, outliers, E3, let's take a look at it, yes.
It's just IQR, but I got it wrong.
No problem.
I got E3 as a note too, so good.
Well, let's take a look. Let's figure it out. I thought I clicked on it, maybe I didn't, I did. Okay. So E3, identify outliers if you use IQR. Okay, so we're doing these guys up here?
Yeah.
Okay, so let me ask you how you attacked the problem. How did you go about doing it?
So I put these all in order. I put them in my calculator for IQR. I did Q3 minus Q1.
Yes.
Which I came up with 500 minus 396.
Okay.
Equals 104 times 1.5 is 156.
Okay.
Which is not
hang on.
the answer.
Let me...
And then
hang on, let me see if I can cheat a little bit here, Madeline. I'm going to try to use Excel to cheat if it's okay. Just to get caught up to you.
So that's 150, yeah.
Hold that thought.
Okay.
Hold that thought.
Okay.
Let me see if I can do this. I might be able to. Yes, I think so. Let me see if I can do. How many data points do we have? We have a bunch, don't we, huh?
Yeah, a whole lot.
Let me select them real quick. I wish I could copy and paste this into my TI, but I can't. So what I'm going to do is I'm going to sort them here.
Oh, we can't see what you're doing.
No,
okay.
you can
You can't see them. Oh, hell, sorry. It's the here.
Yeah,
I just copied and pasted the data into Excel.
Okay.
And all I'm doing, this is why I'm so glad I got you guys using Excel on your out-of-class exams.
Oh, Bosnia is blank.
That's okay, just the name.
Okay.
It's not, the name isn't what I'm interested in right now, just the number of the TIM score. This is one of the most interesting studies I've ever looked at, actually. I looked at it in grad school, and it was talking about, how many of you guys have heard of like Singapore math? Or we should learn math like like Japan. We should earn math like Germany. A lot of those ideas. Can I just do this? How am I going to do this? What if I do a paste special? I don't know if this is going to work. Paste special code text. Let's try that. Oh. This might actually be better. Maybe. Yeah, let's try this. Let me just try doing it this way. Anyway. Yeah, that actually worked.
Oh, yeah, it did. Okay.
Yeah, it just threw the words in it. So basically, what the study looked at was, it looked at these countries. It sent people into each of the countries with video cameras. This was back in the late 80s, early 90s, I believe. It's been done since then. I think I've been an 07 one. And they videotaped lessons. Like they videotaped math lessons in all these different countries. And then they looked at the videos, groups of experts looked at the videos and tried to see commonalities or differences within the cultures of learning. One of the most interesting ones was I remember hearing an audio recording. This is back in, like I said, 91, 92. Of it was an Asian cohort of teachers watching an American classroom. And while the American classroom was in the middle of doing what they were doing, the computer shorted out. And everybody in the room was kind of like, oh, God. The Asian cohort got really upset about it. Like, what the hell is that? They didn't say, what the hell is that? They said, well, what just happened? They said, well, sometimes it happens. Technology breaks. And they're like, what? Technology never breaks. And the point they were getting at was education gets the best budgets in their school districts. So they would never have a computer go down. I had 3 things go wrong in your MD 114 this morning in Math 105. I couldn't install software on my computer because of the administrative restriction placed on my account on that computer, not on any other computer, but on that one. I had to wait 5 minutes for it to boot up. If I try to boot up any time before 5 minutes, it hangs for an hour. And then the light bulb exploded in the projector and I was going to Plan C.
Oh, wow.
The point of this Asian cohort was like, that would never happen because the educators get as good technology as like Google gets in their school districts. Because education is placed at a much higher level in the Asian cultures than it is in America. Think about it. In America, people view math education something to be tolerated and survived, not something to be experienced and loved. Another interesting difference was that they look at the number of things that, and this is what really hit me hard, the number of things that are covered, quote unquote, covered in a math classroom over the course of a term. So if you look at our homework sheet, there are 9 things on that homework sheet. I do that intentionally, right? If you look at a normal stat class and how it's broken down, there's like 30 things. So what I've done with the course is I've stripped out a bunch of superfluous stuff. Remember how much we skipped in the beginning of the book? Skip most of that out, throw that out and say, you know what, that's best served somewhere later. The American mentality is, oh, we'll start learning it in 7th grade. We'll learn a little bit then, a little bit in 8th grade, a little bit in 9th grade, a little bit in 10th grade. And maybe by the time they're in 16th grade, they'll understand it. An Asian culture goes, you know what we're going to do? We're going to stay in this topic for 3.5 weeks until you understand it left, right, up, and down. Then we're going to build on that topic in the next. And then we're going to build. So they never have to relearn anything. Because they realize that math education isn't like a virus, something you catch. Because that's the thing. I mean, some of my colleagues say, oh, I exposed them to it in Math 95. Is it now in their immune system? That's the problem. Is it now like residual in their spine? And it hit me so hard. That study hit me so hard like that. I'm like, wow, if I strip down the course and have fewer overall topics and tie them all the ones I have together, maybe it'll result in better learning. I hope. It seems to. I hope. So anyway, here's the data. Now, what I'm going to do, I'm going to cheat. Madeline, I'm going to cheat a little bit. I'm going to look at the percentiles of this. So you did Q1 and Q3, the command in Excel, and I'll have you guys using these commands in your take-home exam. Quartile of this data. Is 6 10 the highest value?
Yes,
Do you remember? Okay, it was. Oh, shit, that's right. Gotta put a percent, gotta put a 1 there. All right, so I got a 396.5 for Q1. Yes, is that what you got?
Yeah. Well, I rounded it to 396. But
that's totally fine. And now this brings up an interesting point, and this is the whole point of question 2 on your out-of-class exam. Percentiles and quartiles are measured differently depending on who you ask. We've had this discussion before. How some, basically the idea is where is the bottom 25% of the data cut off. So the TI and Excel might do slight differences, as long as we're in the same ballpark.
Yeah.
So I'm going to call that 396.5, call that Q1. I'm going to come back over here, recalculate Q3 by putting a 3 in here. 499.5, does that sound about what you got?
500, yep.
500, beautiful, Q3. Okay, so there's my quartiles. Interquartile range with the difference of that, IQR, we're going to do equals that minus that. Okay, 103-ish?
104, yep.
104, good enough for government work, literally. Now we're going to multiply that by 1.5, yes?
Yeah.
We're going to multiply that by 1.5. So 1.5 IQRs is going to be equal to 1.5 times that number. 154.5 or 155, I'm assuming for you?
I actually got 156, but...
Well, again, ish. I mean, it's probably just rounding, and that's totally, you're not getting like 602.
No.
So we're in the same ballpark here, I'm happy.
Yeah.
So now what that tells us is, we now have, since Excel can't do this, I'm going to do a box plot on the board of this data too.
Okay.
Just because Excel can't do it. Well, I can, but it's not worth our time to learn how to do it right now. I'm going to make a box plot of this data, so we'll need a few more things.
Oh wait,
That tasted awful. I gotta meet, what the hell?
There,
Oh.
you got a
Yeah,
weird thing.
No, never mind, you know what, I'll do it over here. I'll just change this to 2. There, 463. Now I'm guessing you guys didn't find the median for this one because you didn't have to. Because you don't base the IQR calculation off the median, you base it off the quartiles. What I'm going to do up here is I'm just going to draw a quick box plot of these scores. It looks like they go from 309 to 600. So I'll just start it down here at 300. 300 here, 400, 500, 600. Okay. The min is the 309, so we'll put that guy like here. Q1's 396.5, that's real close to 400, yeah? The median is 463, so here's 450, yeah? So 463 is going to be like here. The Q3 is almost 500, like that's right up against it. There's your box. Now remember, you didn't have to do this.
Bless you.
That, hold on.
You could, yes. You can do this in your TI, yes?
Yes.
If you put the data in L1, you bang out a box plot, it's gonna show you the outliers if there are already two. But Excel just doesn't do it very well. And the max was 610. So we're gonna smidge over 610 out here. That's probably a little too far. So here's a box plot. So using the visual of IQR, this 610 might be an outlier, maybe. It depends on how well I scaled everything, which I'm looking now as I look left to right, and it looks like my hundreds were getting longer as I went left to right. That might be a problem. But if I take that, multiply by 1.5, and then stack on that guy might be outside of it, but it also could be due to the fact that I didn't draw it very well. So that's why I like what we're doing with Madeline's calculation. I think we should go with the calculation. Now, your TI, of course, if you have this data in your TI, you simply run a modified box plot, and it shows you if there's an outlier. Patrick, go.
So I tried to put all this in my calculator. I don't know if I just have something set wrong.
Maybe. Was it giving you an error?
Yeah.
What was the error? Dim?
Yeah.
Yes.
Go back to your stat plot setup menu, make sure your data or your X list is L1 or whatever list it's in, and make sure your frequency is just the number 1. I guarantee it was L1, L2.
Okay.
This is raw data, yes?
Yeah.
So what'd you say to have?
So make sure that your X or your data, I don't know what, can I look at yours real quick, Madeline, just real quick. I just want to take a look at what the code is.
This is X list and frequency.
X list, make sure it's L1.
Okay.
Frequency, make sure it's the number 1.
Okay.
We have gotten so used to using L1, L2 in here, but that's because we've been using distributions for like the past 2 weeks. But every once in a blue moon, you get raw data like this. And raw data is always a frequency of 1. That's it. Now it'll graph just fine.
I thought it was
Yeah.
right, but just
You were if you had a distribution. But we got raw data, so it's a little bit different now.
Okay.
Cool? All right. Now, I'm going to continue with this calculation because I like it. I'm pretty sure this guy's safe and not an outlier. He's not too small. He's small. He's the smallest, but he's not too small. The question is that 610 too far out? So I'm going to take this calculation. I have to take that 1.5 IQR and stack it on top of Q3. Now I can tell it's going to be too big, yeah? It's going to be past that 610, I think. Let me do the math. Let me get some accuracy here. So if I do Q3 and add to it the 1.5 IQR, this is what the IQR method does, right? It takes that 1.5 and stacks it on. Let's do that. That's going to be equal to that plus that. So it's at 654. That's the score that would be the biggest usual score, which would be out here. somewhere like about here.
Is that 499 plus 154?
499, that's Q3,
Uh-huh.
plus the 154 gives us, that's whatever that is, 654 in there.
Okay.
So that tells us that if we've got a Tim score bigger than that, then it's an outlier.
Bigger than 654.
Yes, ma'am, that's the cutoff. I'm not going to bother doing the low one because there's no need to. We know this is going to be wrapped up in whatever it is. So it's obvious, the fact that I drew it so piss poorly is skewing it. And the more I look at it, the worse I feel about how I drew it. Because look, that's 100, and that's 100. Sorry. So it looks like this 610 is an outlier based on the way I drew it, so I inadvertently biased the representation of the data. Are there any outliers based on that? No, there are none. 610 doesn't fall outside of the range, even though I drew it to make it look like it did. I inadvertently did that statistics. I apologize. I'll be available for floggings later. Madeline, does that make sense? Is that fair?
Yeah, yeah.
Good, good. Apologize for the graph. But your TI, please realize, we did a lot of math right then. Your TI, if you choose to do the IQR, just do the modified box plot.
Modified box plot.
Which is choice 4, not 5. The box plot's choice 5 on your graph screen, yes? Choice 4, which is the box plot that shows little dots sticking off the end of it, that shows you outliers. Run that.
Okay.
If there are, it'll show you where the outliers are. Okay? The trick is making sure that you get the thing set up right so it actually shows it to you, because otherwise, I'm sorry.
No, I'm sorry.
Okay, so,
Go ahead, Madeline.
so, let's see, so your answer was 242, I got 240, that would be okay?
242, my answer is
Your
242.
answer was 242, I came up with 240.
That sounds like rounding to me. Yep.
Okay.
Oh, and remember up here, these bad boys, this was done in Excel. I don't remember where I did that. It could have been by hand. It could have been done in the TI. That's statistically equal to me.
Okay.
We're not getting 700 and 242. That's what I'm not concerned about.
Okay, cool.
Cool? Excellent. Thank you. Perfect. Anything else? Please, Wanda. Yes.
I have a question about the project. For the bang theory, you know, the exclamation point?
Oh, yeah.
Okay, so do you, I know I learned this in 105, but I can't remember. Do you take like 9?
Hold that question till break. We'll come back to that. I don't want to freak people out with. I want to cover exam stuff right now, and the projects are standalones. They're not on the exams.
Oh, okay.
We'll get it at break. I promise you. I promise you. I'll answer that question. I promise you. Anything else from either outliers or from? Let me back out to the homework sheet here. So we got outliers. We've got and probability distributions. Anything in there? We're going to do more of the probability distributions in class today. I promise you. We're going to create something. Danny, go please. Thank you.
In the probability
Yes, ma'am.
distributions, it was
Let's talk.
asking you to try to like fix the data.
Fix the data. I like the sound of this.
I was wondering if there was an easier way to figure out those numbers.
Which one are you looking
trial
at
and
in
error.
particular?
Well, like E1 and E2, it says to change the roll of 3 5s payout, and then in the second one it says to change the ante. And so I was just plugging in different numbers to try and.
There is good. Thank you. That's fine, but that might drive you insane
Yeah.
just because of boredom after a while. Like, oh my god, right? Exactly. There isn't. Let's work through. Let me look at E2 real quick. Change the. Let's work through E1 together, and then let's get you started on E2. And then once you see how E1 progresses, E2. And I think I made a note of this in class yesterday in the other 243 class. I don't have any answers for these. And the reason is because every time I run these experiments in class, I get different probabilities in the distribution, so I can't really have an answer underneath, but I realize that's kind of a cop-out. What I can do is just create some numbers myself, and then make videos for this. So I apologize for not having those quicker. We'll just do it right now then. So, remember Chuck-a-Luck? Did anybody still have the results from the Chuck-a-Luck? You got it, Danny. Good. Let's get that on the board. We're going to come back to this momentarily out. So what I'm going to do is, let me stop this guy again. It's pointed at the sky. Well, I guess it's okay. Oh, the duct tape's coming loose. Son of a bee. It is pointing at the sky. Good thing my dulcet voice will still be audible. Just load the stand for now. This is where the Asian cohort would freak out. Why do you have duct tape on your stand? You have the best camera available. And as a punk rocker, I'd be like, dude, duct tape's the best. Okay, so run me Chuck-a-Luck again. Run me the game of Chuck-a-Luck. Am I recording? I don't think I am.
So it was like,
Yes.
I didn't see any fives, you lost your dollar.
Good. We're betting on 5. Yes.
Yeah.
Good. So if you don't see any 5s, you lost your dollar. So let me just. I want to make a couple pre-columns to the distribution, and then we'll get to the distribution in a minute. So the old distribution of Chuck-a-Luck looked like this. So actually, I'm going to make it 3 colors. So this won't technically be in the distribution. Number of 5s seen. I like the fact that you said seen too again. That was good. So if you're going to roll 3 dice and we bet on 5, and you're either going to see 0, 1, 2, or 3 5s. That's what you're going to see. Okay. Now you bet on 5, so the payout is going to be commensurate with how many 5s you saw. So as Danny just said, it's going to say x equals number of 5s. Oh no, excuse me, x equals the payout. So if you don't see any of the 5s that you bet on, what's your payout?
-1.
Good, it was -1. Remember, you lost your ante. Good, very nice. What if you saw 1?
0.
It was 0 because you won $1 back. It's a 1-to-1 payout. 1-to-1 payout, beautiful, which nets you nothing. If you see 2 5s, you clear 1 because it's a 2-to-1 payout, which means you profit $1. And if you see all 3, you win 9 because it was a 10-to-1 payout. Beautiful, beautiful. And what Vegas has to do, and this is just Chuck-a-Luck, a tiny game that's hardly even played anymore in Vegas, they have to adjust these payouts for all their games to make sure that A, they make money, and more importantly, B,
You keep playing.
you keep playing. Make the game attractive enough to keep people playing and keep them losing. That's the whole point, right? And the games of chance especially. Games of skill are trickier. Games of skill are trick, blackjack, poker, because you can beat the odds in those if you do things like counting cards and things like that. But a game of chance like this is pure chance. You can't control anything. The bird cage spins, the dice fall, and that's what happens. I mean, I guess you could control it illegally, but then they kick you out and probably arrest you. If you card count, they just kick you out. They can't arrest you for that. But here's what I need from you guys. What were the chances of these things happening? And this is what varies from class to class because we're doing simulations to get them. What was the chance of losing the dollar that you bet?
0.5738.
5758, thank you. 0.5758. Okay, how about the chance of winning your dollar back?
0.3415.
3415, thank you. How about the first positive payout?
0.758.
758?
0.0758.
758, right, 7%. Good. The other class had about a 697 right there. They were a little bit lower than you. What did you guys have here?
0.0067.
6.7. That was almost exactly what they had. It's interesting because both of those are a smidge high. They should be closer to 0.005. I think it might be 0.005 exactly. No, it's not. It's below 0.005. It's 1 in 216. Theoretically.
Right.
That doesn't mean that we would have seen that in our trials.
Right. That was the bottom one was 1 in 216. The top one was 125/2.
Exactly, but 1 in 216 is actually less than this, theoretically, correct?
Oh.
If you do 1 in 200 is 0.005. Because 1 in 100 is 0.01, 1 in 200 is 0.005, so 1 in 216 has to be below that. So you guys actually saw too many 3 5s. Remember that? You remember that? When we were just sitting in the back going, where are all the 5s? Boom, 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 and then we got a whole bunch of them, then I sat down and stopped talking for a while because it blew me away. So this is the distribution, and the average of this was what? What were your average winnings?
-46.
Nice. We lost 46 cents per game.
40.
Oh, it's 40 even.
Yeah.
40 cents. Thank you, thank you.
Oh, really? I've got it. Wait. I've got negative 0.4397.
44 cents?
Yeah.
Well, hell, let's recalculate it. That's the best part. Exam practice. Here we go. You want a sample exam problem? This is what I'm toying about doing with you guys. Giving you something like this and leaving that one out, giving you 5 points for figuring out what has to go there,
Wow.
Okay,
and then asking you to find the average of the distribution.
would that be better?
That's what, well, both.
I like that.
You like that? Yes, I'm thinking about that as a potential exam question. Like not this distribution, but something like this. Could you figure out what has to go there without using Excel?
Yes.
If I took that away and asked you what has to go in that spot, could you tell me what it is? This is good. Let's stop right now. Let's pause. Let's pause. If I took this away,
Would you?
if I took that away and asked what number has to go right there, how could you tell me that it has to be? Now this is not, I wouldn't use these numbers. These don't sum to exactly 100%. If you notice there's a rounding error, it's Excel rounding error. I wouldn't give you a rounding error on your in class. I make it sum to, so give you the answer. I would make it sum to exactly 100%. So if I took away one of these, yeah?
Yeah, just 1 minus the total of all the probabilities.
Absolutely. Take the probabilities that I've given you, take them away from 100%, and whatever's left has to be what's missing. Is that fair? So this plus this plus this plus this equals 100%. I'm going to give you all but one of them, which means you can find the last one. Yeah, that's all.
Okay.
It's like a weighted average where it's like a nicer version of the problem I gave you guys back in the day when I said, what do you have to get in this term to have a cumulative GPA of this? It's a nicer version of that. So I'm thinking about that, then find the average of it once you're done. So that's a nice little 10 points on your 50 right there. So anyway, let's come back to this problem. Do it on time. Let's figure this damn average out. We're getting a lot of disagreement. I like that. I mean, I want us to have an average though, because the problem. And if you guys tried the in-class quiz from last time, the one I said bring back the rest of it, did you guys catch the beauty of that New York lottery game? Wasn't that amazing?
Yeah.
They were losing money on average, and then they changed the payouts on it because they didn't do what we're doing right now. They didn't pay attention to the break-even points. And these kids were clever enough to catch on to it, which begs me to ask the question, I wonder how many times this happens over the United States over the course of a given year, but it's not noticed. I mean, I fail to believe this only happened one time and these kids just happened to catch it, right? It probably happens way more than we realize. So the next time you're in wherever, look at those Keno machines. Check the payouts on the Keno, which Keno is essentially the same thing as this game they're playing here. And just look at the payouts, do the calculations, or bring them to me, whatever. We'll do the calculations together. And if they screwed up, we go in together and make a lot of money. Because think about it. The average in that game was negative something, right? Negative 41 cents. So essentially, that's like walking up, handing them $1, and saying, give me 59 cents back, I'm going to leave now. Because that's what that is, right? On average, you're going to lose 41 cents every game. So just walk up, hand them $1, ask 41 cents, or ask 59 cents change, you walk away. And then do it again. And then do it again. And then do it again. That's what gambling is. Except you're having fun when you're gambling. You're not just getting crappy change. As soon as they changed the rules, you were then making, was it 19 cents per? That's like walking up to them with your hands in your pocket, take one out and go, I'll take my 19 cents please, and then walk away. Then go back, take my 19 cents please, take my 19 cents please. See the difference? Huge. You're making 20% interest. No bank account on earth pays you 20% interest. No savings account on earth pays you regular 20% interest without high volatility. So these kids went nuts when they found this out. What the hell? They were still losing at the exact same rate. The game didn't change, right? They still lost with the exact same probability that they lost before, which meant they were losing more than they were winning. But when they won, the amount they won made up for what they were losing, and it actually made it positive. That's what the New York Commission forgot to check on. Totally badass, yeah? That's what we're doing right now. We're making sure we can control for that. So right now, the old game, let's figure this out. The old game had an average of coin flips in 105, 0, 1, 9, 0.5758. There we go. And I'm going to do a real quick side trip here. The sum of L2, yeah, look at that sum. It's 0.9998. So it doesn't sum to 100% because Excel had some truncation errors in the count. No big deal. Happens all the time. Happens all the time. It's close enough to 100% for government work. All right. So we run. Sorry. What?
Put the rest of the numbers in there.
Oh, sorry. Well, it's just these guys.
Oh, thank you. Okay.
It's just those guys.
Thank you.
One of our stats, yes. Make sure you get L1 and L2 in there, because if you don't, it's going to look like you profit 225 every game, which is ridiculous because you don't. You have to make sure you do the weights. So L1, comma L2. I get negative 44 cents.
That's so weird. What did I do wrong?
Say that. What's so weird? Tell me what's so weird. Stace, go.
I got a totally different answer for some reason.
When you did just
Numbers.
check your zeros. Make sure there's enough zeros where there should be.
Oh, I see what happened.
I'm getting negative 44 cents. Yes.
That's what I got.
So we get an average loss of negative 44 cents. Fair enough? Awesome. Awesome.
Okay, good.
Okay, good? All right. Now, we need to change it. We need to change the payout here so that this average becomes what?
Positive or zero.
0. We're going to find the break-even point for this game. Break-even point from the. It's called statistically fair. It's also called a statistical dead heat. Sometimes if you look at it from a different point of view. But basically, what you want it to do is you don't want the player to lose money, but you also don't want the casino to lose money or the player to gain money. You want nobody on average to win anything extra than they started with. So if you walk in with $100, after a long period of time, you walk back out with $100 on average. The casino starts with a humongous bankroll. At the end of a bunch of play, they still have their humongous bankroll. So in other words, the only payoff is the fact that you got to gamble a bunch. And money traded hands. People lost, people won, people lost, people won, people lost, people won.
No.
Oh.
I'm lucky.
Thank you
you're
very
lucky
much.
That didn't.
Yes, well that's why I put the 3-year warranty on it. Because I am me. We'll do the old school. And I'll see if I have duct tape in my backpack and break. No, thank you for catching that, Christina. Much appreciated. Gonna be kind of ghetto today, friends. Hope you don't mind. We'll come back. Last night I took this thing home to fix it, and I couldn't find a bolt long enough. I wanted to bolt this thing through the crank arm. But because I waited till 8:30 after I got Max to bed to look for the bolt, I couldn't go over to Lowe's to get the bolt. Did it on the way home. Thank you. So, we have to adjust the game now, but just the payoff for 3, yes? So we gotta make a new distribution. This is gonna be the statistically fair. No, I didn't say that. What was the term? Is it just, it's called fair? What was that? I used a phrasing at home. Statistically fair?
Statistically fair.
Statistically fair, yes. For some reason I second guessed myself right there. Statistically fair distribution. Now there's a lot of ways you can do this, and Danny's pointed out 2 of them. One way is to fix the ante so it's fair. One way is to fix any of the payouts so it's fair. And we can fix any of the payouts. We can fix the payout for 3, we can fix the payout for 2, fix the payout for 1, fix the payout for 0. But I said to use 3, just because it's the most powerful one and it's what Vegas will do, like the lottery did. We'll come back to that one. Okay, so, in other words, we're going to make a new distribution. The probabilities are going to be exactly the same. The probabilities are going to be exactly the same. They're going to be 0.5758. They're going to be 0.3415. They're going to be 0.0758. And they're going to be 0.0067. What else is going to be the same is 3 of the 4 payouts. Say that again.
Oh, I was going to say the numbers.
Say that again.
The number seen is going to.
Oh yeah, for sure. These are the same. I just put this on for reference. We get these numbers. These 3 are going to be the same too. You're still going to lose your dollar ante. This is your payout column. Payouts. You're still losing your dollar if you don't roll any 5s. You're still getting a dollar back if you roll 1 5. You're still getting a second dollar if you roll 2 5s. But the question is, how much should you get for the big 3 5s in order to make the average winnings now equal to $0? So the question is, what goes here? What goes there? What do you think? Let's have some guesstimates right now. 2. Well, it can't be 2. What's it have to be more than?
9.
It's got to be more than 9,
Okay,
right?
sorry.
Because no, this is good. This is good. Thank you for saying that, actually. Because if we have 9, the average is negative. So it's going to have. This has to go up. Because if you think about the components that make up the average, like we did in class last time, the individual components. This individual component is negative. That's pulling the average down. This individual component is 0. That's leaving the average exactly as it is. This individual component is positive. We've got to get this individual component more positive. And since we can't change this, we've got to change that. Yeah? Since we can't change this, we've got to change that. Probability is going to be 0.0067. So the question is how do we do this without guessing and checking? One way is just to keep going in your TI and mess around. Well, let's kind of do it slightly old school. Slightly old school. I'm going to move the camera a little bit. Might need some light too. Yeah, we can probably finish this up before break. Then we'll come back and look at E2. Let me slide this in, maybe. Oh, no. Oh, that's not bad. That'll work. May I, with your permission, what I want to do is I don't want to use 1 bar stats on this. I want to do it manually, because I think that'll be easier, believe it or not, than trying to constantly change the payout until we get the answer to be right. So what I want to do is I want to look at the average over here, old school. Old school, i.e. 5 weeks ago. Which is that times that, plus that times that, plus that times that, plus that times that, divided by the sum of that, but that's just equal to 1, so we don't have to divide by that at all. So remember, when you, this is, I'm saying remember, this is a week old, so you might not remember this. But it's okay. But to find the average of any probability distribution, call it mu now, it's okay to call it mu, because we have the entire thing outlined for us. All you've got to do is add up each random variable times its probability. Now, that's a weighted average. That's the data times its weights. But you guys are going to say, yes, yes, but you have to divide by the sum of the weights for a weighted average. And of course you do. But the sum of the weights is always what in distribution? It's 1, so there's no need to have to do that. All we got to do is this. Hey, that's good. So now let's write this all out. That's going to be -$1 times 0.5758. That's the amount of money contributed by losing, by never seeing 5s. This is in dollars, yes? This is in dollars. This is the, I'm going to do this in different colors so it's not quite as obvious as what's in black. Because it's not important for the computation of the number, but I'd like you guys to see what the hell this is doing. This is the amount of the average contributed by rolling 0 5s. So on average, I'm also going to, if you don't mind, I'm going to bring down that number. On average, you're losing almost 58 cents when you don't roll 5s. Now remember, that's worse than the average of 44 cents lost, right? But that's because there are other components to the average when you don't roll 0 5. Sometimes you roll 1 5, sometimes you roll 2, sometimes you roll 3. Fair enough? So we have to account for all those. Remember doing this last week? You can say no, of course. But last week I did this with a single die where I broke down the average as opposed to each die and each probability, and I said this is how many pips are contributed by 1s, by 2s, by 3s, by 4s. It's the same thing. Every average is made up of different components. We did the same thing with the insurance policy. Each component, each component, each component, each component. So now we're going to add to that the $0 times the 34.15. Do it this way? I think it ends up being easier at the end of the day because it's less guessing and checking. You get right to the answer you need directly. So this would be the amount contributed by gravity and small pence. By the amount contributed by rolling 1 5. That's confusing. 1 5. And that would be 0. Exactly. Yes, that's 0. That's nothing. That contributes nothing to the average, which means you're still down. This is one of the reasons the game is so appealing. You're losing 58 cents and gaining nothing roughly 92% of the time.
Your little orange text up there, should that be 0 5?
No. If you roll 1 5, they give you $1 back,
oh,
but you bet $1 in, so it cancels and you net nothing on average.
Gotcha.
Is that that's just this component though, Nick. We've got 2 more components to talk about, yes?
Okay.
We've also got to talk about the amount of money on average we gain when we roll 2 5s. Now how much is that profit? Positive $1, but it only happens how frequently? 758, yes. This is the amount on average.
Wasn't it 458? Sorry. It's 0.
Oh, it's a 7. I just wrote it terribly. It's a 7.
It's a 7. Oh.
Sorry. Let's not make it worse than it has to be. 458. So now this is the amount we average when we roll 2 5s. Yes? And that's a whopping 7 cents. Right? 0.0758 cents. So now what's happened is, this is actually kind of clever. This exactly cancels 758 over here. So now you're down to a net loss of exactly 50 cents. So you're in the hole 50 cents. This is where the 3 5s are going to save your butt. Because now what we have to do is we have to figure out how much are we going to pay you when you hit 3 5s, which only happens this often. How much are we going to pay you so that this value right here enables this whole thing to add up to 0? That's the whole point. We want this to cancel the negative 50 cents. So in other words, what does this have to equal? Positive 50 cents, yes? That negative 50 cents, that never works out that beautifully. Thank you, namaste. That negative 50 cents has to get canceled by this guy over here. So then it just becomes a linear equation. It becomes question mark times that. 0.0067 has to equal 50 cents. So we divide by that, and we see what it is. 50 cents divided by a probability of 0.0067 gives us how much we're going to pay him?
74.6.
Let's call that 75 bucks. Let's call that 75 bucks. Now, technically speaking, and I wouldn't ever dock points for this, it would be 76, wouldn't it? Because you have to account for the $1 you bet. But let's just call it 75 because that's an easier number to use. This means 75 to 1 payouts are the break-even point. Why does Vegas like to know that? Why would Vegas like to know that a 75 to 1 or 76 to 1 payout is the break-even point?
Because then they could do like, hey, it's a 20 to 1 payout or something.
Because they know if it's usually, that's exactly right, Danny. They know if it's usually 10 to 1 payouts. They can have like Freaky Friday when it's 30 to 1 payouts. And then what happens?
Still bank money.
They're still going to bank money, not as much as they were before, but what's going to happen most likely if they have a payout like that?
People are going to play more.
More people are going to play. And I guarantee they've got numbers on that said if we raise it this much, this many more will play, this much, this many more will play. It's worth it once in a while to get them more traffic in. And then, hey, if we put Chuckle Up right next to the craps table, they're going to walk by Chuckle Up, oh, craps! You said, right? Give them free drinks, give them free drinks. Liquor's cheap. I used to bartend. The markup on a single serving of alcohol over a bottle is staggering. Staggering. I mean, it's an amazing economic model, a casino. It's amazing. I love walking through them. I always feel dirty when I walk in. Usually because I'm declining in Vegas when I walk into casinos. But then I walk around and I'm like, oh my God, I can feel the money being hemorrhaged out of these people. But it's an amazing economic model. Where else does that kind of money get hemorrhaged like that? Besides big business on Wall Street. Disneyland, right? But at least you're getting something from that.
They both look at oxygen.
Yeah, probably. Yes. Please, Katie, yes?
You might have just missed this, but where did you get 0.5?
Oh, this
Okay.
plus this is negative 0.5.
Okay.
So that means this has to be positive 0.5 to cancel and make that 0.
Okay.
That's all. I mean, it basically becomes a linear equation that has to cancel itself. Please, Luana.
I don't understand where you got, okay, when it says 1 over there, you said 2 when you was...
Oh, no, this is how much you're profiting. It's a 2 to 1 payout, but you bet $1 to play. So when they hand you 2, you only profited 1.
Oh.
That's why 9, started life is 10.
Oh.
Does that make sense? Everybody, if you would, move the camera again. I'm going to run and get some tape so I can fix this correctly, because this is a pain in my butt. Grab your TIs, rerun the distribution, but change that payout to 75 bucks. It won't be perfect, because we had to round off, because I think Dan, you said it was like 74.96 or something. It's close enough, though. Grab your TIs, rerun the average, and then we'll get it even closer by using your exact value. Just use 75 for right now. So stat edit, everything's the same except where it says 9 down there. Let me erase this, we don't need this anymore. Change that to 75 and rerun your average.
So will we put 74 actually?
No, put in 75. It should be 76. 76 to 1 payouts, but make it 75. I see what you're saying. And it's really, it's not that big of a deal when you're talking about numbers this large, but pull it 75, that's the closest. Running one bar stats again, look at your average. 0, 0, 2. It's a little bit above 0, yes? It's a little bit above 0 because we rounded up. It was 74 point something, 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 yes? So watch this. See if I can see how close I get it to 0. I'm going to be a total math bastard here. I'm going to put 0.5 divided by 0.0067. There. Look at all those decimals I got for free. Okay, you ready? Total bastard. 0. Boom. There you go. So then now you know your break-even point exactly to 2 decimals. I would never ask you to do that. That's way too math bastard. Way too math bastard. But the point is that now you see what you have to do to get that average zeroed out, and now you can mess with the minds of those playing your game, get them to spend more money in your casino. It's genius. It's freaking genius. Now, I mentioned something earlier that casinos can't mess with this, and they don't for the most part. I don't think crooked casinos last very long. But what they do is they watch the results of these and make sure that they're acting like this over long terms. You've heard of casino machines being hot. They're on a hot streak. Hot streaks are completely, just to prove that hot streaks exist in Math 105 today, I called up the decimal expansion of the number pi, 3.1415, to 100,000 decimal places. And I said, go in there and find some interesting stuff. And somebody goes, holy crap, there are 6 9s in a row. And there are. If you go down far enough, there are 6 9s in a row in pi. And there were 3 6s in a row in a couple different